Okay, so this is sample paper 5, paper 2. So sample 5, paper 2. The diagram shows a quadrant of circle with center 0, 0. So quadrant is like a quarter of a circle, as you can see, with the center 0, 0, as shown, and a radius of 4. So 1, 2, 3, and 4. Okay. By completing the table below, find the y values for each of the x values shown. Give your answer exactly to 2 places of decimals. So to do this, we can just go to the table function in our calculator, and what we can put in is the square root of 16 minus x squared. Okay, and we can do that from 0 to 4. Step of 1. And as you can see, we have the table is now complete on the right hand side, so it doesn't matter of filling it in. Now in tests, be sure also to show your workings, okay? So what we would get here is 0, 4, which is the first one, 3.87 for the second one, the third one being 3.46, the fourth one being 2.65 when it gets rounded up, and finally part 4 being 0. Okay, now we also have to show the workings of this, okay? So what you can do here is, by completing the table, you might want to show the workings for this. So you can say that when x equals 0, y equals the square root of 16 minus 0 squared, x equals 1, y equals the square root of 16 minus 1 squared. When x equals 2, y equals the square root of 16 minus 2 squared. When x equals 3, y equals the square root of 16 minus 3 squared. And finally, when x equals 4, y equals the square root of 16 minus 4 squared. So right now we have our table complete here, okay? Now next order of business, use the trapezoidal rule, okay? Now the trapezoidal rule is a way of using algebra basically to get the area. So if you imagine we're looking for the area of the quarter of the circle, that's what we're going to get next, okay? So what the trapezoidal rule is the area of an object is approximately h over 2, where h is the gap between successive lines, okay? And then it's going to be y1 plus yn. So this is basically y1 means the first, yn means the last, and then plus 2 times y2 plus y3 plus dot 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 plus yn minus 1. And what that means is 2 times the remaining. Okay, so that's 2 times the remaining numbers, okay? So what we're going to do next is we're going to use the our arrows here, and we're going to put in our heights, okay? Now our heights are the values we just obtained in the graph to the right, okay? So what we can say is that h1, this one here is h1, h1 is 4, h2 is 3.87, h3 is 3.46, h4 is 2.65, and h5 is 0. Okay, so, and remember a h value equals 1 because there's a gap of 1 between each and every one here, okay? So it's going to be 1 over 2, y1, excuse me guys, it's not h2, it's these are all y's, okay? So this is y1, y2, y3, y4, and y5. Excuse me, y1, y2, y3, y4, y5. So let's put them into the number. So y1 is 4, the last one is 0, plus 2 times the remaining, which is going to be 2 times 3.87, plus 3.46 plus 2.65 close the bracket. Now we can do this in one swoop in the calculator. So all we have to do is just change the mode back to the normal mode, and what we can get here is 1 over 2 bracket 4 plus 2 times 3.87 plus 3.46 plus 2.65, double close the brackets, and what we should get is 11.98. So it's 11.98 square meters. Find the area of the circle quadrat in terms of pi using the formula for the area of a circle. So the area of a circle, the area of a full circle, this in your notes, is pi r squared. So the area of a quarter of a circle would be a quarter pi r squared. Okay, so in terms of pi, what we need to do here is we just need to get to the calculator, put 1 over 4. Now we want to multiply a quarter by pi. Multiply by pi. And the radius is 4 squared. Because remember we said earlier that the radius, so this can be 4 pi. But remember we said that the radius is a distance of 4. Okay, so it's going to be a quarter pi times 4 squared, and that answer is going to be 4 pi. Use the answer in parts B and C to estimate pi to 2 decimal places. So basically, the answer for B equals the answer of C. This means that 4 pi equals 11.98. Therefore, pi has to be, the 4 is multiplied on the left, which makes it divide on the right. We know it's multiply because there's no sign in between the 4 and the pi. So what we get is 11.98 divided by 4. And what we get here is 2.995, which if we round it off comes to 3. Okay, next one. The size, the mean, and standard deviation of 3 sets of data are shown. What the size means is how many people you may have surveyed. So you surveyed 150 13-year-olds, 2,250 5-year-olds, and 70 16-year-olds. The mean is what they averaged. Okay, so the 13-year-olds averaged 17, the 16-year-olds averaged 5-year-olds averaged 16.5, and the 16-year-olds averaged 23. The standard deviation, which refers to how close the results are together, or the competitiveness of the results, is what standard deviation means. So we can see that the lower standard deviation means more competitive, as in the results were less spread out. So the 13-year-olds were the most competitive, or the least spread out. The 5-year-olds were also quite competitive, but the 16-year-olds had the biggest standard deviation, which means that these results were the most spread out, and also it was the least competitive. Okay, so the biggest sample is the 5-year-olds. And the number of samples was 2,250. The data in the set of something is more spread out than data in other sets. Which one has the highest standard deviation? That's going to be the 16-year-olds. The sum of the results for the sum of all the results for the 5-year-olds is, now what the sum means is the total. Okay, so the total results, the total score. And the total score equals the mean multiplied by the number of students. Okay, so if each student averages 17 and there was 150 students, this means the total score was 17 multiplied by 150. And that's going to be 2,550. Okay, the mean of all three sets is, so to get the mean of all three sets, we need to get the total of all three sets. So the 13-year-old total, or sorry, the 3-year-old total. No, it's the 13-year-old total, excuse me. The 13-year-old total is equal to the mean, what we just did a second ago, the mean multiplied by the number of students. So it's going to be 150 times 17. Sorry guys, excuse me, for the 5-year-old result, I took down the wrong mean and number of students. The it was 16.5 multiplied by 2250. I did actually the 13-year-old one. So it's going to be 16.5 multiplied by 2250, and that's going to be 37,125. Okay, so to get the mean of all three sets, what we need is the total of all three sets divided by the total number of people in all three sets. Now, to get the we already know the mean of the we already know the total of the 13-year-olds. Oh, sorry, we already know the total of the 5-year-olds. So the 5-year-old total is going to be 37,125. The total of the 13-year-olds is going to be, we're going to just multiply the average, which is 17 by 150. And 17 by 150 is 2,550. And then we're going to get the total for the 16-year-olds. And the 16-year-old total is going to be basically your 70 people multiplied by 23. So 70 by 23. And we're going to add them together. And that's going to be 1,610. Now that we've got the total of all three of this, what we can do next is we can just use these numbers. So the three numbers in question. And what we can do is we can add them together to get the total of, sum of the results. Okay, so the sum of the results, so we're going to get our, if you will, our 37,125 plus 2,250 plus 1,610, and that means that the total result is going to be 41,285. Okay, now total number of students, or total number of students that were used, we're going to look up the top. The total number of students is 150 plus 2,250 plus 70. So 150 plus 2,250 plus plus 70 equals 2,470. Okay, and the mean therefore is going to be equal to 41,285 by 2,470 divided by 2,470, And what we get there is going to be 16.7. So the new mean is 16.7. Okay. Now what question E is referring to is the empirical rule. And what the empirical rule is the following. It means that if you have a standard or normal distribution, the mean lies in the center. Okay. And if you take one standard deviation away from the mean and add it onto the mean, so this is plus, this one here will be minus one standard deviation. And this one's plus one standard deviation. You'll end up getting 68% of all the people in between these two numbers. However, we're looking for 95%. And 95% is in between two standard deviations. So basically, if I get the mean minus two standard deviations and the mean plus two standard deviations, I can find out what range is 95% of the entire population in between. Okay, now this is a learn off. The only other one is 99.7%, which is plus or minus 3 standard deviations. Okay, so now that I know it's the mean minus 2 standard deviations, what I need to do next is I need to just go to my top and calculate them. Okay, so the mean is for the 16-year-olds is the mean is 23 and the standard deviation is 4.2. So the mean is 23 and standard deviation is 4.2. So this one here is going to be 23 minus 2 times 4.2, and this one here is going to be 23 plus 2 times 4.2. Let's go straight to the calculator. 23 plus 2 minus 2 times 4.2. And we get here is 14.6. Okay, so 14.6 is the lower score, and the upper score, all we gotta do is just change this into a plus. And what I get here is going to be 31.4. Okay. F. If all three sets are combined and the median results are most likely to be the value in the set of. Now remember that in total, the total number of students is 2,470. Okay, 2,470. The majority of these students belong to the 5-year-olds. Remember, out of these amount of students, there's 2,250 5-year-olds. This means that the median, or the middle person, is most likely going to be in this set. Okay, so it's going to be off the 5-year-olds. Remember, the median means the middle value, and the middle is more than likely going to be in the 5-year-olds. It's going to be a 5-year-old because the majority of the results are 5-year-olds. Okay. Next one. AD and DC are tangent to a circle O and radius. Tangent to a circle with center O and radius 8. So the radius here is going to be 8. So what we can do is we can just join these 2 points here together. Okay, and we know that both these are a radius of 8. Now, if ADC is 30 degrees, find the length of the minor arc AC to 1 decimal place. So what I want you to find out is how big is this here. Okay, so what we need to do is we need to construct a line going from the middle part here downwards. And what this does, it bisects the angle, so that now becomes 15 degrees and 15 degrees. Now the rule about tangents is that they cut at 90 degrees. Okay, and now we know that this part here is 75 degrees and this here is 75 degrees. Now what we know about arcs is that the length of an arc, if we go to our tables, L equals 2 pi r multiplied by theta divided by 360. And what this means is that if we're looking for the length of an arc, So in your tables, let's assume that the red part here is the arc L, and this is the angle theta, and this is R. Theta in our is going to be 150. So theta is going to be 150 degrees. The radius is 8. This will mean the arc here is going to be L equals 2 pi multiplied by 8 multiplied by 150 divided by 360. And what we can do is we can enter that directly into the calculator. Okay, so we're just going to enter that directly into the calculator and see what happens. So 2 pi multiplied by 8 multiplied by 150 divided by 360. Now as you can see, I seem to have forgotten my 8 back here. Now we can see that that turns out to be 20.94, and I want it to one decimal place, so it's going to be 20.9 centimeters. Okay. A semicircle with center O is inscribed inside a right angle triangle. So this semicircle is inside the right angle triangle. The points B, O, and C are collinear. So B, O, and C are on the same line. Okay. It's a right angle triangle, makes that 90 degrees. And what we do is once we define the length of BC. Now what we can see from this is it's very much a right angle triangle. Okay, so just to draw this quickly over here, what we'd have is 13, 5, and this here, call X BC. Okay, so this is BC here, what we're going to call X. Okay, so we'll just get rid of that quickly. Now, we're going to use Pythagoras' theorem, where the longest side squared, and this only works for right angle triangles, the longest side squared equals the sum of the squares of the other two sides, so equals 5 squared plus x squared. We're going to get 169 for 13 squared, 25 for 5 squared plus x squared. 25 for 5 squared, and x squared remains x squared. We're going to bring the 25 out the other side, so we're going to get 169 minus 25 equals x squared. X squared is going to equal 144, and therefore x has to be the square root of 144, and that equals 12. Okay, find sine theta and hence find the radius of OD of the circle. Now once again, if we take our semicircle, what we have at the very beginning, we know that this is 5, we know this is theta, and we know that's 13. And remember SOHCAHTOA, sine is opposite divided by hypotenuse, cos is adjacent divided by hypotenuse, tan is opposite divided by adjacent. We're looking for sine, so we're looking for O divided by H. So sine theta equals O divided by H, or opposite divided by hypotenuse. The hypotenuse is the longest side of the triangle, which is 13. The opposite is the angle is the side that's opposite the angle, which is the number 5. So sine theta is 5 over 13. Okay. Now, find the radius of OD of the circle. So we're looking to find what OD is. Okay? So, the radius of the circle. Now, okay, so now that we know that sine theta is 5 over 13, we're going to try and figure out what the radius of this is. Okay, so to figure out what the radius is, what we need to do is we need to have a look at we need to write down a letter for the radius. And we're going to call this letter R. Okay? Now remember earlier that if that's R, then this full length is 12, and that will make this length in here 12 minus R. Now if we were just to write out the length of the BDO, okay, so BDO is here. Okay, so this triangle here is BDO. Just denoted by this one here. That's BDO there. So what we have is theta is here. We know that this angle here at D is a right angle, and the reason why it's a right angle is that it's a tangent. It only touches once, therefore it has to be 90 degrees. Okay, and then we know that this here is 12 minus R. Okay, and what we also know is that this here is the radius. This is R. So in a way, we have the opposite and the hypotenuse. So the opposite of this triangle is R. R is the opposite, and 12 minus R is the hypotenuse. So what we can say is that sine theta ends up to be R over 12 minus R. But we already know that sine theta is 5 over 13. So what we can next do is cross multiply the two of these. And what we'll basically get is 13R equals 5 into 12 minus R. 13R equals 60 minus 5R. Bring over the 5R to the other side. So 13R plus 5R is 18R. 18R equals 60. R therefore equals 60 divided by 18. So just go and check your calculator for that. And it's going to be 10 over 3 or 3.333. So R equals 3.333 or 10 over 3. Okay. Next question is question 4. 1, 4 is a point on L, find K. Now remember, if you have a line and a point is on the line, when you replace when you get this point, such as 1, 4, when you replace the equation of the line with x equals 1 and y equals 4, the equation of the line must balance. So we're going to get 2 times 1 minus 3 times 4 plus k equals 0. We're going to get 2 minus 12 plus k equals 0. Minus 10 plus k equals 0. Minus 10 gets brought over to your side. K will therefore equal plus 10. So k equals plus 10. The line Q is parallel to L and passes through the point 5, 2. Find the equation of Q. So Q is parallel to L. So find the equation of Q. What find the equation of Q means is it's a line. So we're asked to find the equation of a line. We're going to look into our maths tables and we realize the equation of the line is this here. Y minus y1 equals m into x minus x1. Now first of all, we got to figure out what we know. We know that it passes through the point 5, 2. So therefore we know what x1 and y1 is. The only thing we have left is to find the slope. Now it says it's the same slope. Parallel means it's the same slope as L. So we have to find the slope of L. Now to find the slope of L, there's another formula in your notes. And we also know that k is 10 at this point in time. So the other formula in your notes is y equals mx plus c. And what mx plus c means is that if I get y on its own, then whatever number comes in front of the x is the slope, because m is the slope, okay? So what we're going to do is we're going to get y on its own, bring 3y over the other side, so we're going to get 2x plus 10 equals 3y. We're going to turn this around so that 3y equals 2x plus 10. Remember, the y has to be on its own, so we're going to get rid of the 3. It's multiplied by 3 on the left, which makes it divide by 3 on the right. And now we know that the slope of this line is whatever number comes in front of the x. We now know that the slope is 2 over 3. So slope equals 2 over 3. Now what that will do is it will bring us back to our original formula, which is up here. We now know the slope is 2 over 3 and we know the point is 5, 2. So what we can do next is we can just put in here y minus y1, which is going to be y minus 2 equals 2 over 3 into x minus 5. It's multiplied by 3 on the right, or sorry, it's divided by 3 on the right, which means it's multiplied by 3 on the left. Multiply 2 in here and we get 2x minus 10. So what we're going to do next is we're going to multiply this out and bring the 2x and the minus 10 over the other side. So what we should get here is we should get 3y minus 6 minus 2x plus 10 equals 0. Then we're going to get minus 2x plus 3y plus 4 equals 0. Another way of presenting this answer would be to multiply across by minus 1, which is the same thing, and this is also the same answer. The lines L and Q together with the line y equals 4 and the x-axis form a parallelogram. Find the vertices of the parallelogram and sketch the parallelogram on the grid below. Okay. So the lines L and Q together. So we need to write down the equation of L and the equation of Q. So we know that Q is going to be 2x minus 3y minus 4 equals 0. So I'll just rewrite that. We know that Q is 2x minus 3y minus 4 equals 0. And we know that L is the line 2x minus 3y plus 10. Now, what we also know about, to draw a line, we need to know 2 points on it. Okay? So, what we already know about Q is that Q contains the point 5, 2, because we've already been given that about Q. So Q contains the point 5, 2. We need to find out another point that Q contains. So what we could say is when y equals 0, we need to find out what the x value of Q has to be. So remember, when y equals 0, this means that, we're going to draw it up here, right? So when y equals 0, what we're going to get is 2x minus 4 equals 0, 2x equals 4, x equals 2. So we know that the point 2, 0 is also on this line. So it goes from 2, 0 to 5, 2. So 2, 0 is here and 5, 2 is up here. So what we can do now is we can just do a line that goes through both of them. Okay? In both directions. Okay. Next one. We know that 1, 4 is a point on L. So we can write down the point 1, 4. So 1 to 4 is here. Okay. And what we can do next is find a point that's on L. So once again, let y equal 0. And this time use L's formula. So we're going to get 2x minus 3 times 0 plus 10 equals 0. 2x plus 10 equals 0. 2x equals minus 10. X equals minus 5. So now we know that when x is minus 5, y is 0. So this is the point minus 5, 0, which is going to be here. So what we're going to do is we're going to join these two lines together, like so. And now we have the beginning of a parallelogram. Now what we're also told is that the line y equals 2 and the x-axis. So the x-axis is this line here. So that's part of it. And then the line y equals 2, which is this line here. Now we can see the formation of a parallelogram. It's this part in here. We can see the green part here is the parallelogram. Okay. So it just wants us to sketch the parallelogram on the grid below, which is now done. Okay. The points A, which is minus 1, 2, B, which is minus 3, minus 4, C is 3, minus 6, and D is 5, 0, are vertices of a square. Vertices means these are the corners of the square shown here. Okay? Find the coordinates of the center S. Now, the thing about squares is that we can find the midpoint of the diagonals is going to be the center of the square. So we can see that the diagonals bisect each other. So we just get the midpoint of AC, and that should be enough to get the center of a circle. So we go to our maths tables and we get the midpoint formula, which is going to be x1 plus x2 over 2, y1 plus y2 over 2. So we're going to use A and C here. So we call A x1, y1, and C x2, y2. So what we're going to get for the midpoint is we're going to get minus 1 plus 3 divided by 2. And on the other one we're going to get 2 plus minus 6 divided by 2. Once again, we can make this quite easy by just going straight to the calculator and just entering in our numbers here. So the first one's going to be 1, and the second one 2 plus minus 6. Just make sure to use your brackets always, prevent any easy errors occurring. And that's going to be minus 2. So 1 minus 2 is the midpoint is the center of the circle. So it's going to be 1 minus 2. This is also the center of BC. Now, find the equation of S. So to find the equation of S is a circle. So we're looking for the equation of a circle. So once again, we go to our notes, we get x minus h squared plus y minus k squared equals r squared. So what we're going to do next is we're going to look for we have to figure out what the radius is. Okay? So the radius is the length of S here to any other spot. So we're going to do S to A. Okay? So the center. So we're going to do the center here is going to be x1, y1, and A is going to be minus 1, 2. Okay? So A is minus 1, 2, which is going to be x2, y2, and the center of the circle is going to be 1 minus 2, which is going to be x1, y1. Now the radius is a distance, so at the moment we're working on the radius. The radius is a distance, so we're going to find out how long the radius is by using the distance formula. Once again, it's in your notes. So the distance between 2 points is going to be x2 minus x1 squared plus y2 minus y1 squared. So what we're going to get here is the following. We're going to get minus 1 squared plus y2, which is 2 minus minus 2, close bracket, to be squared. So once again, let the calculator do all the work for you. And we should get the square root of minus 1 minus 1 squared plus, just going to delete that quickly, plus 2 bracket minus 2, close the bracket again and square it. And what we should get is 2 root 5. Okay, so the radius of circle. Now, if we just look at this, we've actually sort of made an error on this. This is actually too big. It's not actually the radius of the circle at all. So, excuse me about that one. So what I actually needed to do was I actually had to find out this, the radius of here, or I can find So what I needed to do was I needed to find out the radius, okay? So what I could have done was I should have got the midpoint of AD. So get the midpoint of AD, which will put me here, and then get the distance of here to here to find the radius. So I need to get the midpoint of AD instead. So I made just a quick mistake, wrong way of doing that. So we're going to find out what the midpoint of AD is starting off. Okay, so the midpoint of AD. So the midpoint of AD is going to be 5. A is minus 1, 2, and D is 5, 0. So we're going to actually just get the midpoint of these ones. So midpoint, once again, it's the midpoint formula of what we just did a while back. So it's going to be minus 1 plus x2, x1 plus x2. So it's going to be 5 plus minus 1 divided by 2 plus y1 plus y2 divided by 2. So 0 plus 2 divided by 2. And what we're going to get here is we're going to get 4 divided by 2, which is 2. 2 divided by 2, which is 1. So this is the point 2, 1. So we know this point here is 2, 1. And we know that the center of the circle is 1 minus 2. Now we're going to use the distance formula. Okay? So we're just going to rub out A and D here. So we're no longer using these. We're using the point 2, 1, which is this point here. And we're also using the point 1 minus 2, which is the center of the circle. So when it says the equation of S, we're looking for the radius of the circle, and the radius of the circle was these two here. Okay, so what we're going to get is we're going to use the distance equation again, which is the square root of x2 minus x1 squared plus y2 minus y1 squared. So this is going to be x1, y1. This one here is going to be x2, y2. So the distance therefore will equal so x2 is going to be 1. 1 minus 2 squared plus minus 2 minus 1 squared. And we're going to put, when we put this into the calculator, what we should get is the following. So we're just going to just alter what we had a minute ago. So it's going to be 1 minus 2 squared plus minus 2 minus 1 squared. And we're going to get root 10. So the radius, the distance is root 10. So the radius is now root 10. So that brings us back to the equation of the circle formula, okay? So we can get rid of this here. And we've just had to find out the radius is root 10. Now, what h and k stand for is the center of the circle, the coordinates of the center of the circle. So we know that h is 1 and k is minus 2. So you can put these in here, and we're going to get is x minus 1 squared plus y minus 2 squared equals root 10 squared. So we're going to get is x minus 1 squared is grand. Now we can put in minus 2 here if we want. So minus bracket minus 2. All it turns out to be is plus 2, so it's going to be y plus 2 squared. And then finally root 10 squared is basically, just make sure to put it into the brackets, otherwise it might not turn out. And that gets you 10. So the equation of our circle is x minus 1 squared plus y plus 2 squared equals 10. Now, the circle x plus 4 squared plus y squared equals 10 is the image of S under the translation PQ goes to 6, 5. Find the value of P and the value of Q. So what I'm going to do is I'm going to draw out both circles, okay? Now this circle here has x minus, once again, if it obeys the general rule of circles, x minus h squared, y minus k squared equals r squared. So r squared equals 10, r equals root 10. You can see that the radius is the same size as the original circle, which is what we expect as it's an image under a translation, okay? And what translation means is basically you're moving the spots of the circle, okay? What we know about the circle as well is that basically it has, we know that minus h equals plus 4. Therefore h equals minus 4. And we know that k must equal 0 because there's nothing here. So k equals 0. So we know that this circle has a center of minus 4, 0. While the old circle had a center of 1 minus 2. So if you can imagine, we just draw these for a minute and just draw an xy axis here. Now root 10 in the calculator, if we press change, is about 3.16. Okay, so just bear that in mind, 3.16. So we're going to draw the original line, which is 1 minus 2. So go across 1, down minus 2. So we just need to drag this x-axis up a bit more evenly. Alright, so down, cross 1, and down minus 2. And this is the center of S, okay? And we know that S is a circle that has a radius of 3.16, so just around here, okay? And then we know that this new circle comes along and it has a center of minus 4, 0. This puts it around here, and it also has a center of root 10, so it goes across 3 and a bit. So you can see that both circles are identical height, but where did they get moved? Where are all the points getting moved to? So to find out how the points get moved, we just compare the centers, okay? So we know that the circle gets moved across this much and up this much. So it gets moved across 1, 2, 3, 4, 5, across 5 and up 2, which means add minus 5 to x and plus 2 to y. Okay? So this means that whatever point comes before this, you had to take away 5 from x. So this would make this point 11. Okay, because when you take 5 away from 11, you get 6. And when you add 2 to y, you get 5. So this makes this point 11, 3. Okay. Next question. Draw a triangle ABC with sides BC equals 12, AB equals 9, and AC equals 10.5. In order to do this, what I'm going to do first and foremost is I'm going to draw out the longest base, which is the side BC of 12. Okay, so we're just going to draw out the length of 12 here. Okay, so that's my length of 12. Now what I'm going to do next is going to get my my protractor, or my compass, sorry, excuse me, my compass. And what I'm going to do is so this is B to C, is located here. And what I'm going to do first and foremost is I'm going to do A to B, which is 9. Okay, so I'm going to do 9 centimeters here. So we're just going to go back here and we're going to measure up 9 centimeters. So we're going to spread this across until we have 9. Okay, and we can move this up. And we're going to make a big dash here. Okay, now as you can see, I just didn't fit it in properly. So just going to make a big dash here. Now the next one I have to do is I have to turn the next one into 10.5. Okay, which is going to be quite a stretch. Now, it turns out my compass isn't big enough to do this, so I'm going to have to go back to the very beginning. And what I'm going to do is I'm just going to make this a bit smaller. Okay, so that will work this time out. So once again, I'm just going to repeat the procedure. I'm going to draw B to C. Once again, another 12 centimeters this time. Okay, just come down with the rubber. Make sure it's exactly 12 centimeters. Now you want to be very accurate with this. This is why you do all your constructions in pencil, because you just want to be really accurate when you're drawing. Okay, so just want to. Okay, now that we've done that, what we're going to do is once again, this is the sides B and C. And what I'm going to do is I'm going to measure AB, because that has to link to B, and it's going to be 9 centimeters. Okay, so get my compass in again, and I measure 9 centimeters. Okay, so this is going to be 9 centimeters here, and we're just going to make a mark up in the sky like so. Right, so that's our first mark here. Then we're going to come over, and we're going to do a 10.5 length line for AC. So we're just going to make this wider until we get to 10.5. That's pretty much it. Just make sure it's flat. As accurate as you can get it. Okay, so 10.5, that's pretty accurate. Then we're going to swivel it around, start this at C. Then we're going to go up and see where the lines meet. And then after that, we can just draw a straight line from B to the point of intersection. We know that this is A, and we know this here is C. Okay, so this is the triangle ABC. On this diagram, draw a line parallel to BC through D on AB such that BD is 6 centimeters. So what it wants me to do is it wants me to draw a line parallel to BC. So once we draw a line parallel to BC through AD, line parallel to BC through D on AB such that BD is 6 centimeters. If this line intersects AC and E, write down the values of AE and CE. Okie dokes. Okay, so what we can get asked to do here is the following. Okay, so this is from a junior cert one mixed in. So what we're going to do is we're going to draw a line on AB that is 6 centimeters long. Okay, so we're going to make sure that's parallel to BC. So 6 centimeters long, we'll have it at this mark here. Okay, so this red mark here is the point D. Okay, now that that's done, what we're going to do next is we're next going to get our compass out, and we're going to draw an arc. So we're going to go through the construction for doing a line parallel. Okay, so we're just going to take this in. Okay, now this can be any distance you want. I suppose a reasonably small one, and we'll do it in a different color pen so we notice the difference. Okay, so this is an arc here, and just quickly go up, and an arc here. Okay, call these arcs X and Y. Now, use the compass, draw XY with B as the center. So B is the center here, okay? Now place the point of the compass on X and stretch it to Y. So what we're going to do next is we're going to measure the distance from X to Y. So this distance here, okay? So we're just going to rotate the compass for a second. And we're going to measure the distance of X to Y using the compass. Okay, so it's about roughly correct is what we're looking for. Okay, so there we go. We got the distance of X to Y, okay? So now, once we know the distance of X to Y, we're now going to go up and go up to D and use this as an arc, okay? So what we should get here is we'll get this line here. The first one. Okay, and wherever this cuts the line, we'll move this up here. And then we'll draw our second line, so where it cuts. Okay, and what we should have is a line parallel to BC. Now, what happened to me here was, I think I made the first line, original line, just a bit too big. Okay. So what we're going to do here is just quickly take this away for a second. Okay, so this center XY, it actually made it go out of range, okay? So we can see that it's just a bit too big at the moment, okay? So what we can do here is the following. Okay, so we're just going to go back to where we began. Now the mistake was more or less made here, okay? Although the arc can be as big as you want, sometimes it's not practical to have it in as large as you'd like, so because it wouldn't fit into the top line. Okay, so we go again. There's our first one. There's our second one. Okay, now that that's done, step number 2 is going to be measuring X to Y. So we know that this is the point X and this is the point Y. So we're just going to measure the two of these together. So as it turns out, it's roughly XY already. So that's too far. Just got to bring it in a little. And that's more or less it there. Okay. So now we're going to go to point D and we're going to do this arc. Okay. So the first arc is going to hit the axis. We can call this point M. And then once we've done that, we can draw the cross. So if you have point M here, we're going to draw this arc all the way down. And then we're going to go up to point M and draw another arc down. And what this gets you is your parallel line. Okay, which is what we're looking for. Okay, and there we go. Okay, and what it says is that the point where it intersects is the point E. So this is this point here, and this is the point E. Alrighty, now write down the values of AE and CE. Okay, so what we have at the moment is we have two triangles. We have basically 3 triangles inside of each other. Okay, so what we can do is we can just write up a quick mock-up diagram here. And what we know is that BC is 12. We know B to C is 12. And we know that B to D is 6. And if B to D is 6, we know that B to A is 9. So that will make this one here 3. Okay? So write down the value of AE and CE. Okay, so AE and CE. So what we got to remember here is the proportions are the same. So AD divided by BD is the same thing as AE divided by EC. So what this basically means happens here is that this AD is going to be 3 over 6. Okay, so what that means is that, which is the same thing as a half. Okay, so 3 over 6 is a half. So what this means is that EC equals 2AE. So EC is twice AE. Okay, so EC is twice AE. So if you imagine this here is going to be 2x and this is x. Add them together and you get 3x. So you know that the 10.5 is broken up into 3. It's broken up into 3 different into 2 different parts. So 10.5 equals x plus 2x. 10.5 must equal 3x. X is therefore 3.5. This makes AE 7. So what this will do is it will make AE 7 and AE 3.5 and EC 7. So it's going to be 7 and 3.5. Say Y triangles ADE and ABC are equiangular. Okay. The reason why they're equiangular is basically if we're to draw out the 2 triangles in question. So ADE is the smaller triangle and ABC is the bigger triangle. What we could say is that, now please remember these 2 lines are parallel, okay? So we can say is the angle, so just give them numbers, angles 1, 2 and 3, angles 2, 4, 2, 3 and 4. Okay, so angle 1 and angle 4 are equal. This because they're corresponding. Angle 2 equals angle 2 because it's the same, it's a common angle. And finally, angle 3, or sorry, not this, that's not angle 3, that'll be angle 5. Angle 3 equals angle 5. So this here is angle 3, and this one here is going to be angle 5. Angle 3 equals angle 5 because they're corresponding angles. Alright, hence they're equiangular. Hence write down the value of DE. So we need to find out the value of DE. Well, what we can say about DE is the following. We can say that using, if you will, a scale factor of both of them, we know that the smaller triangle, which has DE is what we're looking for here. So this is ADE. We know that this is 3. We know that this is 3.5. We know this is 10.5. And we know that this here is 9. And we know that that's 12. Well, what we can see is that this triangle here is 3 times bigger. It's an enlargement of 3. Okay? So because it's an enlargement of 3, this means that DE has to be 3 times smaller. So this makes DE equal to 4 because the scale factor is 3. Okay, that concludes the end of this video.